All right, ladies and gentlemen, today we are taking a look at Notes 4.1. We are looking at Notes 4.1, and we are beginning our function unit. So Unit 4 is all about functions. Now, we want to start with some vocabulary words. So you're going to hear us talk a lot about domain and range. I want you to know that domain is the set of first coordinates in a relation, and it's all of the x values. It's all of the x values. You want to fill that in. And range is the set of all the second coordinates, and it's the y values. Basically, it's all of the y values. A function is a relation in which none of the first coordinates repeat. In other words, all of the x's are different. Okay, so I want you to make sure that we're dealing with this correctly. So domain is my x values, range is my y values. So I want you to repeat that just to make sure you got it. Domain is x, domain is x, domain is x, range is y, range is y, range is y. I know it feels stupid to repeat it, but it does make a difference in your brain and how it remembers it. We know it's a function if all the x's are different. In other words, none of the x's repeat. So I'm going to take a look at this first example. I notice that my x values are all of the first coordinates, and I list them: 11, 12, 13, and 9. I know that my range is all of the second coordinates, and so I list those: -2, -1. Now, -2 is in there twice, so I don't have to repeat it, and I write 7. Now, the question is it a function, yes or no? Well, to know if it's a function, we're going to look at the x values right here. Do any of these x values repeat? The answer is no. They're all different, so yes, it's a function. Now, there's something called the vertical line test. The vertical line test is a way that we decide if something is a function by running a vertical line across it. Now I want you to notice, here we're deciding if it's a function by looking at the x values. But here we're taking a look at the graph, and we're going to do the vertical line test to decide if it's a function. And you use this method to determine if a graph is a function or not if a vertical line passes through the graph more than once. Then the graph is not a function. Now, I'm not sure that this is going to let me do what I want to do, so I'm going to practice very quickly. Hold on, I'm going to pause it and come back. All right, I'm back. I figured out how to get it to do what I wanted it to do. All right, so we're going to run a vertical line test. Now, what I do is I take a vertical line, and we're looking at just the graph on number 2, and I run the graph across from left to right. If you look right now, it's only hitting the black line one time. Now, let me color that differently because I want to make sure I'm being very clear. We're looking at this line and this point, okay? So when I'm talking about it crossing more than once, we're looking at the graph, and I'm going to draw them all in blue just so that it's real clear. All right, now let's see if this will work. So I'm going to start by looking at number 2, and I'm going to take my line, my vertical line, that means it's a line that goes up and down, and I'm going to run it across the graph from left to right. So, yeah, I kind of make a sound. So if you look, it's only hitting the blue line one time. Can you see that? Only once, once. But something happens right here. That point is considered part of the graph. And so at this point right now, this graph is touching the vertical line twice. It's touching here and here. That means it cannot be a function. Okay, so let's pick it up and move it again and see, yeah, we're fine the rest of the graph. It's just that one is not a function because of that point. So is number 2 a function? The answer is no. Now let's take a look at number 3. Again, I'm going to drag my vertical line across. Is it a function? Okay, so it's hitting twice. Can you see that it's hitting twice? It's hitting right here and right here. So that means it cannot be a function. So this is also a no. I don't know why they're moving together. There's nothing I can do about that, so sorry about that. It's also a no. What about number 4? What do you think? Can you imagine a line going across, a vertical line? Is it going to hit more than once? Let's go look and see. Yeah, it does. So that's also a no. So when we're doing the vertical line test, if it hits more than once, it's a no. All right, now let's take a look at number 5. We're going to talk through 5, 6, and 7 all at the same time. Okay, taking a look at 5. Once. It's once all the way across. So number 5 is yes. Okay, number 6. Once. It's fine. It's good all the way across. Number 7. Once, like a whole lot of times. So that's a no. So number 7 is a no. Number 6 is a yes. And number 5 is a yes. All right. Now you won't be able to draw that vertical line on your test and move it around, but you can imagine it. All right, let's go to the next page. All right, so we're at the next page of Unit 4 notes. And what we've done is we're saying a point is missing from the graph. The relation is not a function. Now that's important information for us to notice because that means we have an x that repeats. We want to know which point is missing, okay? So we've got 0, 0. We can choose between 0, 0, negative 1, 2, 1, 1, or 2, negative 2. So what I'm going to do is I'm going to go in and I'm going to kind of look at the points, each point, and decide what I need so that it won't be a function. And there are a couple of ways to do that. So I know that my current x values are listed here. We listed that for you. So if I put a point right here on 0, 0, if I draw a vertical line test, I'll pass. So it cannot be 0, 0 because I would add in an x of 0. So I'm looking at where could I add in an x value that repeats. Do we have any x values here that are also listed here? And the answer is yes, it's C. Okay, so if I take a look at C, if I were to plot that point, if I were to plot 1, 1, it's going to go right here. And when I draw the vertical line test, you'll see that it hits the graph twice because it hits 2 points. So it is not a function. So the answer is C. Now let's take a look at this function machine. So inside this function machine, we have a rule. And this rule is 2x plus 3. And it pulls out a y. So I know my domain is my x values. So if I plug in negative 1, so I'm going to plug in negative 1, so 2 times negative 1 plus 3, then I'm going to plug out the number that goes with that. Now I'm going to use this table over here to help me figure it out. So it'd be 2 times negative 1 plus 3. 2 times negative 1 is negative 2 plus 3 is 1. So I know I have a range of 1 for that value. Now I'm going to show it going through the function machine every time so that you can get the idea of how this is working. Now the next x value I have is 0. So I'm going to plug in a 0. So it's 2 times 0, because everywhere there's an x, I'm going to write a 0. So 2 times 0 is 0 plus 3. That's 3. And then what comes out of the function machine is a 3. Now the next one I'm putting in is 1. So I put it in everywhere there's an x. 2 times 1 plus 3. That's 2 plus 3, which is 5. And I get out of 5. So my domain was negative 1, 0, and 1, and my function and my range was 1, 3, and 5. Now, when I put in the negative 1, I got out this 1. So that's my coordinates. That's my x and y value. When I put in the 0, I got out this 3. And when I put in the 1, the 5 came out of the function. Now, function notation is one of those things that people get frustrated with because it scares them, and you really don't need to be scared of it. We've got an equation that's y equals 2x plus 3. If I want to write it in function notation, then I would say f of x equals 2x plus 3. If I say f of negative 1, then what we're asking is what is the function if I plug in negative 1 into everything? So it's f of negative 1 would be 2 times negative 1 plus 3. That means everywhere that there is a negative 1, an x, that's where you'll see the negative 1 come in. And then I would solve it. So for now, function notation is just another way to write y equals. So let's go take a look at number 9. So number 9 says find the range of each function for the given domain. Now they've given me the function, and I know that these are my x values. So that tells me that I need to plug in each of the x values. So I'm going to start by plugging in -2. I've got -2 squared plus 3 equals 1. Now when you plug that into your calculator, make sure that anytime you're squaring it, if it has a negative, you put it in parentheses. So -2 squared is 4. 4 minus, and there, hold on, would give me 1. So I know I have a range. My first value is 1. I'm going to plug in the 0, because f of 0, everywhere there's an x, I'm going to write the 0. 0 squared is 0, so I get -3. So I have -3. Now I'm going to plug in the 2. 2 squared. Now I don't have to put this one in parentheses because the 2 isn't a negative, but I can. So 2 squared is going to give me 4. 4 minus 3 is 1. I don't write down the numbers if they repeat, so I have a range of 1 and -3. You can also do this in your calculator if you wanted to. You could go to your calculator and type in the function and the y equals and click second graph and use the table, okay? Unfortunately, I don't have a calculator downloaded, so we're going to have to do this one by hand. But you can go do it on the calculator and check my work. All right, so I know that if my x value is -4, and this is my equation, then I'm going to say -2 times -4 minus 4. I'm going to say -2 times -1 minus 4. All I'm doing is everywhere there's an x, right? So it's -2x minus 4. Everywhere there's an x, I'm putting in the x value that it's telling me to do. -2 times 2 minus 4. Now I'm going to do those in my head real quickly. I want you to go to your table. So I want you to put this in your y equals. I want you to do second graph and then use the table. You should get -4 is 4, -1 is -2, and you should get 2 is -8. So I know my range is 4, -2, and -8. Ignore the dogs barking in the background. Sorry about that, guys. It would give me 1. Not really sure what. All right. Number 11 is really easy. So they've given you a list of coordinates, given you a list of x values, and they want you to find, they've given you a list of x and y's, a list of coordinates, and they want you to find the y values when they give you an x. So remember, this is h of x. So they're saying x is 6. What does y equal? So what I do is I go look at all of the x values. So I'm looking at all of the x values. Are any of those x values a 6? The answer is yes. So on this one, x is a 6. That means the range, or the output, is 12. Now we're going to do the same on the next one. Okay, so they've told us h of x. They've told us x is -2. So we look at all of our x values. Is there any place that's a -2? The answer is yes, and so 6 will be our range. Now I want you to do h of 8 for me real quick. All right, you should have gotten 14. Any questions? All right, good. Now, you're going to need to use your calculator. I just told you that I don't have a calculator downloaded. I'll make sure I get it downloaded by the next video. So you're going to see me plug things in, but you can just use your calculator. So what I'm going to do is I'm going to write down what needs to go into your calculator, and then you can type that in. Okay? So here we have two functions. It's like having two friends. We have a friend named F, okay, and we have a friend named G. All right, so we have two functions. And the first thing says we're going to use F, and we're going to plug in -2. So F of -2. Well, I know that this is F of X. So F of X is 2 minus 1.3 times X, but instead of the X, I'm going to write 2. So in your calculator, you're just going to type this in. And you should just get 4.6. Now this one says x equals 5, but it says we're going to use g. Well, this is g, so in my calculator I'd say 0.255 squared minus 9.1. Now I put this in parentheses because it's squared, and I've learned over time that kids will always forget to put a negative, so I just get them in the habit of remembering to put it in parentheses if it's squared. You do you on what you want to do there. So I plug that in, and you should get negative 0.285. So that means when g is 5, I get out negative 2.85. That means on the function g, it's 5 and negative 2.85 is a coordinate or a point. Now, I'm looking at number 14. Notice I have actually 3 problems in one. First, I have to figure out what f of 4 is. Then I have to figure out what g of negative 1 is. And then I have to add both of them. So I'm going to go over here on this side, and I'm going to work f of 4. So I want you to remember that this is the function, right? So f of x equals 2 minus 1.3x. So that means everywhere there's an x, I'm going to write a 4. And when I plug that in, I'm going to get negative 3.2. Now I'm going to work g of negative 1. G of negative 1, that means I'm using the g of x function. So that means everywhere there's an x, I'm going to write in negative 1. Now in this case, make sure you put the parentheses around it when you're plugging it in. And when you do, you get negative 8.85. If you get something other than negative 8.85, you didn't put your parentheses in. So that means f of 4 is negative 3.2, and g of 1 is negative 8.85. And my original function says that I'm going to add them. So I use my calculator, and what I get is that they're negative 12.05. Taking a look at the next one, or the last one actually. It says evaluate the following. Okay, so evaluate means that we are going to plug it in and figure out what it equals. So they want us to evaluate h of 4 minus 3. So here, notice these are my x values and these are my y values, or my output or my functions, my h's of x. So this says x equals 4, h of 4. Well, if I look, here's h of 4, my output is 74. So I know this problem is the same as 74 minus 3, which means that equals 71. And it's really that simple, okay? Now, here it says find h of x plus 2 for x equals 2. So that means h of, if x equals 2, 2 plus 2. So they want you to find h of 4. Well, we already know what h of 4 is. We just found it. So if it's h of 4, then that means x equals 4, which means it's 74. So they're really not hard. It's just about, do you understand what they're asking and how they're asking? So this one says we've got 3 times h of x for x equals 0. So they're saying 3, and this isn't how you write it. This is just how I'm thinking about it. 3 times h of 0. Well, that's real simple to find h of 0, because h of 0 is telling me that x equals 0. Well, if x equals 0, then I know my output is negative 10. So this is 3 times negative 10. All right, there's the 3 right there. And we know this is negative 10, which means that equals 30. All right, that's it for lesson notes 4.1. If you have any questions, feel free to go back and review. I want to remind you of a couple of things. This is called function notation. If it has an h of x, a g of x, a y of f of x, and you can think of those as your output or your y values. Also, if it says h of 4, then that means x equals 4. And they want you to find the output, which in this case, where x equals 4, the output is 74. Let me think, what else? Oh, a function, there's a couple of ways to check for a function. One way is it is a function. If it is a function, can the x values repeat? Yes or no? If it is a function, can the x values repeat? The answer is no. X does not repeat. And then finally, the other way to check if it's a function is if you have a graph, you run the vertical line test. Now, I don't think it's going to let me move that line. It's not. But you take that vertical line and you imagine moving it above that. So, hey, ladies and gentlemen, we're taking a look at notes 4.2. So we are looking at notes 4.2. And today we're going to discuss discrete versus continuous. Discrete versus continuous. By the time you finish this lesson, you should be able to talk about the domain and range that can be described by a discrete or continuous function. And let's start by looking at what is a discrete function. So a discrete function is a set of data where the values belong to the set are distinct. That means they're unconnected values. Discrete data is counted. In a graph of a discrete function, only separate distinct points are plotted. So in other words, discrete is counted and it's distinct points, meaning it's dotted. And only these points, okay, so we have distinct points that are plotted, and only these points have meaning. To the original problem. So if we wanted to summarize, discrete x values are only for specific points. Okay, so discrete is often counted. It's dots and discrete. All right, so we said that discrete is counted, and now we're going to take a look at continuous. So continuous is a set of data that can be used to be continuous if the values belong to a set can take on any value within a finite or infinite interval. So continuous data can be measured. In the graph of a continuous function, the points are connected with a continuous line since every point has meaning to the original problem. So to summarize, continuous x values can be any point. Okay, so continuous is connected. Continuous is connected and it's measured. For example, time would be continuous, right? You can have 1 second, 2 seconds, and you can have 1.5 seconds. So everything in the middle also counts. All right, so let's keep going here. All right. A discrete graph will be made up of points that are not connected. In other words, a discrete graph, you can think of it as dotted. Although dotted isn't mathematically correct, it's going to be a bunch of points. Whereas a continuous graph will form a line or a curve. Okay? So let's take a look at number 11. We want to know, first, look at the graphs, and we want to decide if it's discrete or continuous, and then we want to find the domain or the range. All right, so I know that continuous is measured and it forms a line. I know discrete is counted and it's often a list of points or unconnected dots. Okay? So when I look at this line, I can see that that goes on forever and that goes on forever. My question is, does it form a line? Yes, so I know it's continuous. So the domain is my x values. So in class, we use a set of Post-it notes, and it looks like I would put a Post-it note there, but I have the arrow at the end of this graph, which means I don't put a Post-it note there. And so then here, if I were to put a Post-it note for my x values, I've got that arrow, so I don't. So it means that my domain and range, or that my domain, my x values, are all real. Or I could say negative infinity less than x less than positive infinity. Now if I want to look at my y's, I put my Post-it note so it goes across the y values, and I can see that it's y equals 2 right here on the y-axis. And I notice that all my y tells me that my y's are greater than 2. So y's are greater than or equal to, and I said 2 and I meant negative 2. Thank you for catching that mistake. So let's take a look at number 12. First, I want to look at the graph and decide, is it discrete or continuous? Well, it's dotted, meaning there's lots of points. It's not connected with a line, so it must be discrete, which means it's counted. So discrete is counted. So I know this is going to be discrete. Now they want to know what is the domain and what is the range. Well, in order to do that, I'm going to need to list the coordinates of each point. So 1, 2, 3. So this is -3, 4. This one is -2, 1, 2. This one is 1, 3. This one is 1, -2. And this one is -2, -2. So if I were just to list those points out, you don't have to list them out. You could do them on the graph if you wanted to, like I did. Sometimes it helps me organize my thinking if I list them out. So I listed all the points. Let me check. Yep, I did. The domain then would be my x values, and my x values line up right there. So I know my domain is -3, -2, 1, and that's it. I don't write any repeating values down, so I don't have to write this one or that -2 down because it's already listed. Now my range is going to be my y values. So in this case, my range is 4, 2, 3, 4, 2, 3, and -2. And I don't have to write this second -2 down because I've already written it down once. And just to connect back to our previous learning, is this a function? The answer is no, it's not. No. If I draw a vertical line, you'll see that I hit it twice. So if I do the vertical line test, it hits twice, so that means it is not a function. Also, I know that this x value, -1, is repeated, so I don't need to, it's not a function. I said -1, I meant 1. And I think I missed one here. There should also be a -1. Oh, I missed it when I was graphing it. Hold on, let's go back and fix it. That should also be -1 inside that bracket. So ignore that bracket. There it is, my mistake on that. All right, moving on next page. So we're taking a look at 13 and 14. Now when I look at 13, I see that it is continuous, meaning all the points are connected with a line. So if it's continuous, then that means that I am going to, if it's connected with a line, it's continuous. Okay, so repeating. Continuous means it's connected, it's with a line, and it's usually something that's measured, like time or money or distance. Okay? Now the domain, I'm going to take a look at my x's. If I look, this has an arrow, and if I look here at this part of my x axis, that one also has an arrow, which means it's going to go on forever. So it can be all real numbers, or I can say negative infinity is less than x, which is less than positive infinity. You need to be able to show them both ways. That's why we're showing them both ways. Now, if I look at my y values, it looks like it would be between -3 and 2. But one of the things that happens with this arrow is that it will keep going up gradually and gradually and gradually and gradually. And if I go out far enough, it will use every single y value on that axis. So it's going to be all real or negative infinity y less than positive infinity. Again, you need to be able to see them both. Taking a look at number 14. Now, this one has an open circle and a line. That means it's a ray, so we're dealing with a ray. But it does have a line, so I know it's going to be continuous. My points are connected with a line. So just a reminder, if it's connected, if it's continuous, the points are connected, it has a line, and those are measured things. Again, if it were discrete, it would be distinct points, which often show up as dots, and that is something that's counted. I just want to keep reviewing. So it's continuous. I'm going to start by looking at my domain, which is my x values. So I look at my x-axis, and I notice that right here is where the graph stops. It doesn't use any of these x's over here, but it uses all the x's this way. So I know that that is at -4. So if I'm looking at that x value, I know that x equals -4, and it uses all the x's that direction. So my domain is x is greater than -4. Now I didn't put a line underneath it because this circle is open. Because that circle is open, it means that it cannot have the line, that it's got to be greater than. It means that the x value can be -3.999999, or it can be -3.9999999, but it can never be -4. So it can get real close, but it can't be -4. Now, I'm going to take a look at my y values. Again, keep in mind, we're looking at the y values for this graph. I'm looking at my y-axis. If I look at my y-axis, I can see that the graph stops where y equals -1, and it's above. So my y values are above, so I know it's y is greater than -1. Now there's another way to look at it. So I know that this y value is -1. What's that y value right there? It's 5. So is 5 bigger? Yes. So then that helps me remember that it's greater than. It's one way to look at it. All right, one of the other things you have to be able to do is you have to be able to read a situation and draw a rough sketch and decide if it's discrete or continuous. So we're going to decide if something is discrete or continuous, and then we're going to decide how that might look. So the first one is the price of a hotel for different number of nights, okay? So let me think that through. If I were to stay one night, let's say the hotel is $200. What would happen if I stayed 2 nights? It'd be $400. If I stay 3 nights, $600. And I'm making up the $200, right? But that means every night I stay, it increases. Now, will they let me stay 2.5 days? No, they're going to charge me for 3. So whenever I think about it, something that's discrete is counted. That means I count the number of days, and that's how much I'm going to pay. So I know that this is a discrete situation. Now the height of a tree over time. The height of a tree over time. Let me think about that. So a tree starts like that big, and I plant it. And then in a month, it's that big. And then in 2 months, it's that big. Now, does it jump from this size to this size, or does it grow a little bit every day? And does it jump from this size to this side, or does it grow a little bit every day? So it grows a little bit every single day. That means it's constantly growing, or it's continuously growing. So when I think about it, it would start at this height, and then it would grow. Now, at some point, it's going to start to level off. If you just did a line, that's okay. And we would measure the height of the tree. So I remember that continuous measures things. So continuous is connected with a line, and it's often stuff that's measured. All right, Walmart selling bananas by the pound. I had to think about that. Selling it by the pound. They're not selling it by banana. They're selling it by the pound. So if I wanted to go get half a pound, they'd let me buy that. Or if I wanted to go get 3/4 of a pound or a whole pound, or if I wanted 1.33 of a pound, they would let me do that. So it kind of sounds like it's continuous because I can get as much as I want. So if I buy 0, then it's going to go up at a certain rate. If I have 0 pounds, I'm not going to pay anything. So it's continuous, which makes sense because continuous is connected with a line, and it's things we measure. We measure pounds, right? Just like we measure height. We count the number of nights in a hotel. So counting would be discrete. The student council earns $5 for each Howdy Week shirt sold. Okay, so if they sell 1 shirt, they get $5, 2 shirts, $10, 3 shirts, $15. Continue. What if can they sell 2.5 shirts? No, they can't. So it's going to be discrete. All right, so that's notes 4-2. Let me make sure I do some quick review before I let you go. Discrete. The graphs are often points or dots, and it's things that are counted. Nights in a hotel, etc. Continuous is measured, and the points are connected with lines. Okay, so discrete has points or distinct dots, and it's counted things like number of nights in a hotel, number of t-shirts sold. Continuous is things that are measured, pounds, time, weight, etc. All right. That's notes 4-2. Please make sure that you complete the homework and have it ready for class tomorrow. We're done with notes 4-2? Yep, we are.